Hello WOBBLE2 and congratulations on being here on the launch campaign for RX33. Can you please introduce yourself and what you are doing in Kiruna and Esrange?
Yeah, so hello, I'm Matteo. I'm the team leader of the WOBBLE team. We are from the Technical University of Berlin. Yes.
Yeah, I'm Felix. I'm integration lead and did a lot of mechanical engineering and designing parts.
Awesome. And you are here to launch your experiment into space. What is it going to do in space? What's the performance looking like?
So our experiment is about testing tank structures. So they are called propellant management devices, and they are used to control the liquid inside the propellant tanks. And we want to test new of these structure manufactured with a 3D printer out of titanium and scalmalloy. That's a special alloy. And yeah, we have on one side introduced these new materials, but on the other side we also introduced new designs which are now possible with the 3D printing technology.
Felix, I've seen you have a live stream from inside the rocket. What can we expect to see there?
So you can see different fill level of tanks, hopefully, and hopefully some sloshing, and the interactions between those PMDs and the fluid.
Matteo, can you please tell us what are the further applications of the results of your experiment?
Yeah, so with the results we get first knowledge if these 3D printing technology is useful for propellant management devices, and then we could further research in general 3D printing opportunities like for the whole tank. And yes.
That's super exciting. Speaking of exciting, what was your most exciting point in the whole Rexus campaign?
So the most important point is quite here. So being here and having this experience is just great. But the first great thing I experienced was when we started manufacturing, and we had the first things we did ourselves on our hand and could start testing us.
What was your most memorable moment, Matteo?
So there are so many, I cannot even count them. I think it was all the time when we finished a milestone. But it's just also, I would say, here the experience to be here with the team colleagues and just experience the of course the scientific side, but also like the personal side here, looking at auroras and having this nice landscape and just getting this amazing experience.
Thank you and best of luck with your launch in some minutes.
Thank you.
Thank you.
Hey, so hello, Solder X. What is your role inside the experiment?
Hello, I'm Kwasmin. I develop software, and here's Angia. She's my colleague, also software.
And can you explain us what is Solder X about, the experiment?
Yeah, sure. So, SolarX, our experiment consists of doing solder joints in milligravity.
And what is happening during the launch? What do you expect? And when is your experiment successful?
Okay, so during the launch, after 20 seconds, we are starting to heat up our soldering iron. And after 85 seconds, when we receive the SOE signal, the whole process of doing solder joint starts.
Okay, and maybe can you tell us what was your highlight inside the Rexus program, and what are the moments you remember most?
Of course. So we had some moments where everything was working perfectly, and the next day it broke, and then we fixed it, and it broke again. So that's been what's been happening with our experiment for the last year. But it's been a fun ride, and I would do it again if I had the
Okay,
chance.
then we all wish you good luck for the launch, and thank you.
Good luck
Thank
to
you.
you as well.
Your launch will be in about 30 minutes, but you are here already since last Monday. What happened for you in the last days?
Yeah, so we arrived on Monday by plane, and then we received our experiment after it was shipped here to Kiruna. We are now on the Esrange, the European Space Range. Yeah, and then we unpacked the experiment, exciting moment, checked everything, and then we started to make the last fixes. In our experiment WOBBLE, for example, we replaced 2 sensors. Yeah, and then we made finally everything ready. We had the last tests with the team here, and now the rocket stands there over there, and we are really excited.
Felix, can you tell us what will happen in the next 30 minutes until liftoff?
Yes, our experiment will get powered on, and then we received our first data as the rocket is erected, and then we see on the screen how it looks, how the fluid will be, and then we will start 1 pumping cycle, maybe 2, to get the fluid in its determined position, and then the experiment will be shut down, and roughly at T-minus 60 seconds we get power again and start recording, and are waiting for liftoff.
Then the big moment, liftoff, and then it's your big moment. What will happen after liftoff?
Yeah, so I think then it's really exciting for all the experiment teams to see the rocket launching behind us. So the rocket will launch very rapidly, so we have 18 times the gravitational force, and then the rocket will raise quite high, and then the first thing is the despinning, so the rocket is rotating during its liftoff, and to get this spin out of the rocket there's a special despinning mechanism, and afterwards the motor of the rocket will be separated. And then, like for all the experiment starts the microgravity phase, and like these 2 very important minutes where all of the experiment run. Then the microgravity phase will finish, and then I think probably after 10 minutes the rocket will land here on the back in Esrange.
Sounds really good. Felix, can you tell us some words about the rocket you're using?
Yeah, the rocket, you can think about it will be like 6 meters long, a bit shorter. Yeah, and there will be 3 experiments on it, and yeah, it is supposed to reach a height of about 90 kilometers. Yeah.
Then good luck with launch.
Thank you. So very warm welcome, Persis. Can you maybe introduce yourself and what is your role inside your experiment team?
Hi Matteo, thanks a lot. our project PERSIS focuses on photopolymeric extrusion of reinforced structures in space. I am the team lead of PERSIS, and doing so I have the project management responsibilities as well as the systems engineering responsibilities.
Genau. My name is Dennis Klingberg. I'm the organization lead. That means I'm responsible for all the non-technical tasks within the experiment or within the project, and I also support it in all the mechanical and electrical tasks within the project.
Yeah, so Raphael, maybe you can explain a little bit further what is your experiment about and what is like the scientific question you're looking for?
Yes. As mentioned, we are researching an extrusion process in space. Extrusion is one of the manufacturing processes. So on Earth, we already master different kind of extrusion processes. Now we want to research if we can apply similar principles to space. And we are facing different challenges like microgravity, but also the vacuum which we have in space. And now we did some preliminary tests to try to mitigate these risks, and we are going to test it under real space condition with the Rexus rocket.
Okay, so maybe Dennis, can you explain a little bit further what is happening during the countdown, what is happening during the flight?
For sure. So during the countdown, we're having a few checkups beforehand to check that the whole system is working and is responsive. And after liftoff, when we reach microgravity at around 76 seconds, our experiment will start. That means our printing bed will run downwards, our UV LEDs will turn on, and we will start to extrude our resin. And then we hope to see on our camera that we are extruding 4 profiles. And then we can visually check if that is looking good, and then after the flight we will check them in detail and then compare them to the ones we already created on Earth.
Okay, so maybe Dennis, can you explain us a little bit further? You applied for Rexus a long time ago. What happened so far, and what does the normal Rexus journey looks like?
Yeah, sure. So the Rexus project for us obviously is not just a week we are here now, but it started 2 years ago when we applied for the spot on the rocket we are now using. So the first big milestone was the application presentation we had at DLR in Bonn. After that, after we got selected, we started with the design of the experiment. So we first had our preliminary design review, and after that we had our critical design review, which froze our design. So after that we started to construct, manufacture the experiment. And then we had all that done for the bench test, or for the shaker test, where we tested our experiment. And when we met all the requirements there, we set it up here, and now we're here ready to launch it.
Yeah, so happy to have you here, and good luck for your launch.
Thanks, you too.